So hello everyone. The main aim for this video is to show that rational number system have certain gaps, and that rational number system is inadequate for many purposes as a field and as an ordered set. And this gap is what lead us to the irrational number systems. And so we will see in this video that why do we need irrational number systems at all. Okay. So before moving on, I would like to recap something. What is a rational number? And even before that, what is a number system? So, there are many types of number you can say. The most primary and basic one being the set of natural numbers. And this goes like 1, 2, 3, 4, 5, and all the way up to infinity. So, these are the most intuitive type of numbers, or these are also called counting numbers, as you can just count 1, 2, 3, 4, 5. So, this is the first type of number we need to be familiar with. The second type of number goes by integers. And the integers are like from minus infinity all the way to minus 1, 0, 1, 2, and all the way to infinity. And the next type of number here, that is our primary concern, is rational numbers. So rational numbers are primarily written in the form p by q, where p and q both are integers. And prime to each other in the most simplified form. Prime to each other basically means that they don't have a common factor in them. So this is the diagram of a number line. And you can say it's minus 2, minus 1, 0, 1, 2, all the way. So rational numbers were good enough for most of the purposes, but there were certain numbers which did not fit into the scheme of the rational numbers. To show this, we will take the example of root 2. So basically we have to show that there is no rational number such that, let's say m is our number, m square is equal to 2. Or in bracket you can say that this implies m is equal to root 2, just taking the positive one. So this is what we need to show, that there is no rational number such m square is equal to 2. So in order to do that, we can use the mathematical principle of contradictions. So what we do here is, say, let's say that we do have a rational number. So square is, let's not write it like that. Square is 2. So this implies that p square by q square is equal to 2, and that p square is equal to 2q square. Now you need to observe something important. Here lies our answer. So p square is 2 into something, right? Which means that p square is even. Now from basic logic you can say that if p square is even, it must imply that p is even, because an even number square always gives a even number. This is true for all cases. So now if p is even, then p is divisible by 2. Let me write it as that.
2 divides p. Now, if 2 divides p, then 4 must divide p square. Right, this must be the case. So basically from here we proved that p square is divisible by 4. The logic is again simple, I am repeating, that if p square is even, then p is even. And if p is even, that means p is something 2 into something, and that means p square is 4 into something. That's why 4 divides p square. So p square is divisible by 4. So if p square is divisible by 4, then on this equation, this side should also be divisible by 4. But that implies that q square is divisible by 2. That means if q square is divisible by 2, which means if 2 divides q square, that means q square is even, which again in turn implies that q is even. Now that's where the contradiction is. Now the whole thing implies that p is even and q is even. But that's not possible because we told that m is equal to p by q, where p and q are prime to each other. Now p and q both cannot be even. Thus, from here we can conclude that no such m belongs to q, rational number, exists. So there is no rational number whose square is 2, or better to write, root 2 is not a rational number. So indeed, we found a number that is not in the rational number system. So indeed, there are certain gaps in the rational number system which get filled up by numbers which are not rational. So we call this the irrational number. So you can do the similar thing with root 3, root 5. You can show them. So, and this goes on. We have infinite number of irrational numbers. And between any two rational number, you can always find a irrational number. So that's all about this video. I hope you enjoyed it. Thank you.